Alright, day 2 of Chapter 6, Lesson 1, Weather. So that means we're on page 224 and beyond. On this page we have a diagram of the water cycle. So let's go ahead and copy this diagram of the water cycle. And here's what I suggest. Okay, I would suggest making sure we have enough room for like 3 major drawings across. First, I would start by saying water cycle in red, because that's kind of like its whole section, a whole page dedicated to water cycle. Okay, I would draw the sun with arrows coming in saying radiation energy. That's not in our picture, but we're going to figure out why later that's important. Okay, I would start with the water and evaporation here. So a little squiggly line for the water. Arrows going up to the right for evaporation. Okay, and then it says when water evaporates, it changes from a liquid to a gas called water vapor. So I wrote water vapor. Okay, the second picture is a small cloud and condensation. So a small cloud, and I did a little bit of squiggly underneath it, condensation. Arrows going over here, arrows going over here. And it says when water condenses, it changes from water vapor to tiny droplets of water. So I wrote water droplets. Okay, next up is a bigger, darker cloud with rain. A bigger, darker cloud with rain. I kind of used my pencil to shade it in a little bit and make it darker, like a storm cloud. Precipitation, precipitation. Liquid or solid water falls to the ground as rain, sleet, snow, or hail. So I put rain, snow, hail. Sleet is basically just kind of like halfway between rain and snow. It's just a mushy snow. So rain, snow, and hail are your main 3. Okay, then, rather than draw the mountain and the river and all this kind of more complex stuff, I just reminded myself that yes, that water goes back out to the oceans or the lakes or the rivers, and we call it runoff, which causes weathering and erosion. So that's how this whole water cycle ties back into landforms and things we learned earlier. Okay, anything else on this page we didn't read? Yeah, water cycles among Earth's air, ground, oceans, and living things. Energy from the sun powers the water cycle. So they didn't draw it, but they said that energy from the sun powers the cycle. That's why we drew the sun, the 3 arrows. I wrote energy and I remembered, it's not conduction like a metal bar. It's not convection like swirling liquids or air. It was radiation energy from the sun. And then I remembered, well, okay, that warms up the surface, so I put warm in red. And then when it comes up here to condense, it's actually getting cooler, so I put cool in blue. Okay, one last look. You can pause it here if you need to get the whole picture. All right, let's move on. Clouds and precipitation. Clouds and precipitation. Like air pressure and wind, water is an important component of weather. Water is one of the few substances that is found in nature in its 3 states: water vapor, liquid water, and ice. So 3 states, vapor, which is a gas in parentheses, zoop, liquid, zoop, and ice, which is a solid. It's in all 3 forms. Water is constantly circulating between Earth's surface and the atmosphere. This happens in a series of steps that make up the water cycle. Okay, we drew all that stuff between the liquid water, the gas and its water vapor, and then the precipitation and that whole cycle coming all back around. Recall that much of Earth's surface, about 70%, is covered by water, mainly ocean water. Therefore, the oceans are the main source of water for the water cycle. Okay, so Earth's surface, about 70% water, a lot of ocean water. That's the main source. Let's put that. Main, M-A-I-N, source, S-O-U-R-C-E. Okay, there's a lot of ocean water covering the Earth's surface, and that is the main source of the water cycle. This is how you use your notes to string ideas together, connect them, and make complete sentences. Okay, next up. When the sun warms the oceans or other bodies of water, the water at the surface gains enough energy to evaporate. Okay, so it comes into the surface and gains enough energy to evaporate. Energy, evaporation, it's getting warm. Evaporation is a process that changes a liquid into a gas. The warm, moist air rises. The warm, moist air rises. Hey, that's the same thing we learned about sea breeze and land breeze. The warm air rises because it's less dense. Then a few kilometers above Earth's surface, the air cools. Oh, so once it gets up here, high up above the surface in the atmosphere, it cools. In cool air, the water vapor condenses. So when it cools, it becomes more dense, it condenses and comes together to form water droplets. Condensation is the process that changes a gas into a liquid. Clouds are formed from tiny droplets of liquid water or from ice crystals. Okay, so up there in the air, this water vapor is starting to collect into tiny droplets of water. They're still so tiny that they can float in the air like a cloud. Eventually, the water droplets in clouds may grow and become too heavy to stay aloft. Water then falls to the ground as precipitation. Precipitation includes the rain, snow, sleet, and hail that falls from clouds to Earth's surface. So as that water vapor condenses into little droplets of water, or maybe very tiny little ice crystals, they're still floating in the air, but eventually that cloud becomes so big, those water droplets grow and get heavier and heavier, become more dense. Eventually it has to fall to the ground as rain, or hail, or snow. Rain, snow, and hail. And they say sleet quite often. Sleet is just like halfway between rain and snow. It's very wet snow, slush basically, like a slushie. All right, next up, humidity. Humidity. The amount of water vapor in the atmosphere at a given time and place is called humidity. Humidity can vary greatly from day to day and from place to place. Humidity also varies with air temperature. Weather reports usually describe relative humidity. Relative, it relates to something else. Relative humidity compares the actual amount of moisture in the air to the maximum amount the atmosphere can hold at a given temperature. Go back and read that again. Actual amount in the air versus maximum amount can hold. Relative humidity is expressed as a percent. Okay, so relative humidity, arrow percent, because it's expressed as a percent. It's the actual moisture divided by the max it can hold. Okay, so if it's super, super dry, then there's very little that's actually in the air, but it could hold a lot. You'll get a tiny, small fraction percent. At 100% relative humidity, the air is saturated. It is holding all the water vapor it can hold. So 100%, arrow, air saturated. So what that means is if the actual moisture in the air is the most that it can possibly hold, then that number divided by that number is the same. It's 100%. It's 1. And that 100% means the air is saturated. So if it's a very humid day and it feels wet and heavy and you feel hotter just because it feels so heavy, places like Texas and Florida feel that way a lot, then you have very high relative humidity. But if you go to somewhere like Arizona or Nevada, or you're here in the summer where it's very dry, very low relative humidity. The moisture in the air, the actual moisture, is very low, even though it could hold more. Okay, the temperature at which air is saturated with water vapor is called the dew point. If the air temperature drops below the dew point, condensation will occur. Okay? So, if you have 100% humidity, relative humidity, Your air is saturated with all the moisture it can handle. If you add a little bit more water vapor, you're going to get condensation, and you might even get precipitation. Likewise, they say if the temperature drops, that will occur. So, if you add water vapor, or you lower the temperature, things get colder, you'll end up with condensation or precipitation, maybe both. And remember, they go in order. Condensation will happen first, and if enough of that happens, you'll get the precipitation. Okay, so relative humidity is a percent. It's how much moisture is actually in the air compared to what it could hold theoretically. If the air is completely saturated, all you have to do is add a little more water vapor and you'll get condensation like clouds, or maybe precipitation like rain and snow. If the temperature drops, it gets colder, the air can handle less. In other words, warm air holds more water vapor than cooler air. Okay, so warm air can hold more water vapor than cooler air. That makes sense. If lowering the temperature makes that water precipitate, then warm air can hold more. Warm air can hold more energy too. All right, let's look at this little graph here. Okay, water vapor density, and the number is going up. So remember, density is like how much water vapor is in the air. Grams per cubic meter. Gram is a mass, or like an amount. Cubic meter is a volume. So as you go up, you're getting more and more saturation, water vapor. Okay, left and right is temperature. As the temperature goes up, you can hold more water vapor. As the temperature goes down, the air can hold less water vapor. Matches what they told us in the words. Okay, so warm air holds more water vapor than cooler air. Warm air holds more water vapor than cooler air. What causes clouds to form? All right, clouds form because of condensation, right? Okay, what causes the condensation? So we're going to say something like, clouds form due to condensation. The sun's energy warms the surface of the earth, and most of that surface is ocean water. When that water heats up enough, it can evaporate and become water vapor, which is basically liquid suspended in the air. It's a gas. As that warm air with the water vapor in it rises, it gets to the outer atmosphere and it cools. That cooling condenses the water vapor and it becomes tiny little water droplets, or maybe tiny little ice crystals. CRYSTALS. Okay, so we just described what causes clouds to form. It's condensation, and then when we went back and talked about how the sun's energy warms the surface of the earth, which is mostly ocean water. As that water heats up, it can evaporate and become water vapor. Gas is suspended in the air around it. When it gets up there and it's cool enough, the temperature drops, all of that water vapor saturates the air, eventually becomes water droplets or ice crystals, and you get a cloud. Then if it keeps going and they get heavy enough, all those water droplets or ice crystals will get too heavy, precipitate, and fall to the ground as rain, snow, or hail. Okay, let's go on and do air masses. Page 226. Air masses. Air masses. Air masses. Weather can be sunny one day and stormy the next. Such major changes in weather come from the movement of air masses. An air mass is a large body of air that has similar temperature and moisture characteristics throughout. Similar temperature, similar moisture. An air mass can cover thousands of square kilometers. Okay, so movement, arrow, weather change. Movement of air masses causes weather change. Okay, an air mass gets its characteristics from the region over which it forms. 6 major source regions generate the air masses that affect North America. Okay, 1, 2, 3, 4, 5, 6, actually 7. 7. I don't know why they said 6 here and 7 there. Continental polar air masses form over Canada and Alaska. So there's continental polar right there. These air masses are cold and dry. Continental polar equals cold, dry. Continental Arctic air masses are even colder. These air masses form above the Arctic Circle, way up here, and bring bitterly cold weather in winter and cool, dry weather in summer. Okay, so those 2 little quotes right there mean that we're using the word continental again and Arctic. So continental Arctic equals even colder. Continental polar is cold and dry. Continental Arctic is even colder than that. Continental tropical air masses, that's this yellow one right here, form during summer over northern Mexico and southwestern United States. These air masses are hot and dry. If these air masses remain over a region for an extended time, they can cause droughts. Okay, so we're still using continental, but now it's tropical. Hot, dry. Arrow, drought. So continental tropical is hot and dry, and they can cause drought. Continental tropical, hot, dry, drought. Maritime polar air masses form over oceans. Okay, so it's still polar, meaning the polar regions close to the North Pole, but now it's maritime, as in marine, as in the ocean, water. These air masses are cold and moist. Okay, maritime polar, cold, moist. Let's see, where were we? Right here. Those that form over the North Pacific Ocean bring rain, fog, and snow to the coast. Those that form over the North Atlantic Ocean are usually colder. They can bring strong storms to New England and eastern Canada, especially in winter. Okay, so drew an arrow, cold storms. Maritime tropical air masses. Oh, so it's still maritime, it's still water, but now it's tropical. Tropical sounds warmer to me, like the tropics, like the islands. Maritime tropical air masses are warm and moist. Using the quotes again means we're still saying maritime. Maritime tropical, warm, moist. They form over the subtropical Pacific Ocean, the Gulf of Mexico, and the Caribbean Sea. These air masses bring hot, humid weather. They can produce heavy rains and thunderstorms. Let's also put heavy rain. H-E-A-V-Y-R-A-I-N, heavy rain. Okay, so that's what we have for air masses. Now, looking at the picture, all of that makes sense to us, right? Polar is this northern region close to the pole. Arctic is even further up, and Arctic makes it sound cold. Continental means it's over the continent, over the land. Maritime means marine or water, it's over the water. So when you use combinations of those words, you can figure out where it is. Continental, land. Arctic, super cold. Continental, land. Polar, pretty cold. Continental tropical, still land, but tropical, warm. And then maritime means that you're over the water. Again, polar means kind of cold. Canada and Alaska, cold. Tropical means warm, like Mexico, Florida, Southern California, warm. Sorry, warm and hot. They give you a little key down here to color code them. 6 regions produce the air masses that typically affect the weather in North America. The movements of these masses cause weather changes. Okay, so I see 1, 2, 3, 4, 5 colors here. They say 6 regions, so I'm trying to understand what those 6 regions are. All the colors are represented. Let's see, 1, 2, 3, 4, 5 colors. 1, 2, 3, 4, 5, 6, 7 areas. Maybe they're not quite counting continental tropical, because if you remember, continental tropical forms during the summer, so it's not all year long. All right, that was a little bit longer, but you did a good job persevering with the growth mindset. Roar Wildcats!